Okay, so set 113. Yep. Yes. All right. So, set 113 is like the start of a new unit. We don't usually do units in Saxon, as you know. He kind of mixes up everything, so you don't really see a lot of ideas in a row. This is the one exception to the rule. Set 113 all the way through 119 are almost all related to each other. So, you guys know how to solve linear functions, yes? Yes, you do. Please tell me yes. You know how to solve quadratic functions, yes? Now, you do not know how to solve cubics, or quartics, or quintics. Nor do you know how to graph any of those. You will. By the time I'm done, you'll be able to deal with polynomials of any degree, solve it or graph it. And today is the start of that lesson. You've got to be able to do today's lesson if you're going to be successful. So pay attention. Are you ready? All right. Before I long divide this, seniors, I am getting a lot of heat from Miss McSkimmon saying, this seniors can't even divide. Are you kidding me? Some of you can't long divide anymore. Now, I'm not talking polynomial division, I'm talking numbers. So what I would like you to show me is that you can divide this out. I want you in this space to divide 565 by 12. Go. Go until it ends or repeats. Do not even think about using your calculator.
5.
If you don't remember the process or the algorithm for long division, you best come in 7th period and we can review.
I did this on my test. Do you not see that?
Long divided?
Yeah, I always do this on my test, like the margins.
Okay, how long am I supposed to keep going?
Go until it repeats or ends.
It does.
It does. Every fraction repeats or ends every one.
Not very close.
Possible. Not possible.
Not getting there.
Getting there.
Are you getting there, Kate? No. Oh, it repeats. I got it. What? What? Are you getting there? 47 point something? 47? Yeah. 0, 8. 8, 3. 8, 3. Oh, gosh. I hate one. We're used to 56.
12 doesn't even, it's not even hard to find a repeat.
I had 60 divided by 15 is 2, and then it's like 5.
Oh, jeez. Come on. All right, so how many times does 12 go to 100?
47.
Eh?
What? Oh, wait, no, I'm so sorry.
It feels like you should listen to my question. How many times does 12 go to 100? 8. Okay, so that's 96 and 40. How many times does 12 go to 40? 3. And how many times after that? 3. Expressing your answer, is this okay? No, that's garbage. How do you express your answer?
Just 1, 3.
1. You should show the simplest possible form, and it's that. Yes?
Yes.
All right. Now, that said, let's use that process to long divide polynomials. Put x plus 3 outside the box, and x to the 4th. No x cubes. Don't forget your placeholders.
I need an algebra.
Plus x squared plus 2x minus 1 inside. Hey, do you remember your long division of polynomials? Hey, so you look first into first. How many times does x go to x to the 4th?
4.
No. How many times does x go into x to the 4th?
4.
X cubed times. X goes into x to the 4th, x cubed times. X cubed. Now multiply and record it here. X to the 4th plus 3x cubed goes here, right? And what do you do when you have that 48? You subtract, so you change signs. Draw the line. x to the fourth subtracts away, you always want to gradually work right. So you should always see the first term subtracting away like we are here. What do we get when we have 0x cubed minus 3x cubed? Negative 3x cubed, and then what do we do? Bring down the next term, and again we say how many times does x go into negative 3x cubed? X into negative 3x cubed? Negative 3x squared times. Now we multiply and record it in the row below. So what's negative 3x squared times x? Negative 3x squared. What's negative 3x times 3? Negative, oops, cube, sorry. What's negative 3x squared times 3? Negative 9x squared. We subtract that, so we change signs. Draw the line. 3x cubed subtracts away. I get how many x squareds? 8 or 10 or negative 8? What? 10x squareds. Bring down the next term. X into 10x squared. How many times? 10x times. 10x squared plus 30x when I multiply, but I subtract that, so I change signs. Draw the line. Negative 28x minus 1. What was that? What happened there? Who just came in? Who? Oh, gotcha. All right. How many times does x go into negative 28x? Negative 28 times. Negative 28x. What's 28 times 3? 20 times 8 plus 3 times 8.
24 plus 84.
84. It's positive or negative? It will be positive, but right now it's negative, yes? Negative. Change signs. Draw the line. Negative 1 plus 84 is 83. That is the remainder. So how do I express it? 83 over x plus 3. That is the quotient. That is your answer, yes? Okay. Now, would you be interested in doing that in 1/4 of the time?
Yes.
Excellent. Here we go. What I'm about to show you is a little like Kramer's rule, in that it's meant to say, you know what? What really makes the answer is the numbers, not the variables. When you do Kramer's rule, you just strip away the x, y, and the z, and you say, we focus on the number, right? That's what matrices do. Well, synthetic division is the same. You know, you say, I'm going to say, forget the x's, I'm just going to focus on the numbers. So the first thing you do is you put the coefficients of the top, I guess, in a row. Don't forget placeholders when necessary. So I'm going to write here 1, 0, 1, 2, negative 1, where that represents 1x to the 4th, 0x cubes, 1x squared, 2x's minus 1 constant, right? Those are the coefficients in the original problem. You follow me?
Yes.
And again, it's crucial that you put that 0 there for the no x cubes. All right. Then you put the root of the divisor in a box. Here's what I mean. Put a box right here. It looks like that. It's actually the opposite of what you would normally do a division box. You see that? Oh, excellent. So what is the 0? When I say the root of this, what is the 0 of this? So what x makes this 0? Negative 3. All right? Now, leave a empty row here and put a big line there. You're going to leave a space. Don't put that line underneath. There, you put leave a row space. You can put a stuff in that row. And we get going here. Draw a line. Leave a space. All right, so first thing you're going to do is bring down the first number. This guy here, just bring it straight down and put a 1 there. All right? All right, now each time you're going to multiply and record it in the next column. Here's what I mean. Take 1 times -3, which is -3, and you're going to write it right there. Then you're going to add straight down. So 0 plus -3 is -3. Then you're going to do that again. You're going to take what you just got, -3, times the divisor. -3 times -3 is 9, and you're going to record it in the next column. And add. 1 plus 9 is 10. Then you're going to take that 10, multiply it by -3, and record it in the next column. And add. 2 and -30 is -28. Multiply -3 times -28, positive 84. Record it in the next column and add straight down, 83. This row is the coefficients of your answer. So I can see that I have 1, -3, 10, -28, and 83, which is exactly what I see over here, yeah? The only question is, what power should I make my answer? Yeah, the answer is, the variables are 1 less power than your original, because you divided out an x. All right, that's called synthetic division. Are you with me? Okay, so after that, you would say your answer is 1x cubed minus 3x squared plus 10x minus 28, and the last number is the remainder that goes over the divisor plus 3. You follow? You with me?
Yes.
All right. Let's try this then. Here we go. You can see that this must be in descending order. Now, whether you rewrite it or not is up to you, but I would recommend, at least starting out, you say, all right, in descending order, this is x cubed minus 4x squared plus 13 divided by x minus 3. If I put both in descending order, yeah? You see where I'm coming from?
Yes.
Okay. All right, now I write the coefficients of the original problem in the top row. What are the coefficients looking for placeholders? 1, -4, 0, 13. Okay, make sure you look for placeholders. X cubed should have 4 numbers in the expansion. X to the 5th, x to the 4th had 5 numbers. It's always one more than the power. X cubed has 4 numbers in its expansion. What do I put in the box? 3. It's the root of the divisor, or the 0 of the divisor. Okay? Draw a line after an empty row, and get me started. What do I do first? Bring down the 1, multiply by 3 and record it 1 column over, and then add. -1. Multiply, record it in the next column, add. Multiply, record it in the next column, add. And you get 1, -1, -3, and 4. Okay, now that's not my answer, that's just the coefficients of the answer. What's my answer?
X squared minus x minus 3.
Plus 4 over, okay? You try one on your own. You don't have to do this fraction rewrite stuff. You can go straight to the synthetic if you like. You have this done, ladies. Hi, this one? for doing this one. Actually, everybody's already done. You can sometimes expect the numbers to get big. Polynomials do get big. You're fine. What goes in the little box? 3 or negative 3? Negative 3. You'll get really good and really fast at these. Now, chances are, if you did this right, then your last number will match. So when I go to check these, I just see did our last number match. It's doubtful that you're going to make a mistake early and then make another mistake that cancels it out and get the same answer early. So, did you get 164 at the end?
Yes.
Okay, that's great. Now let's write our answer. What's the power of the first variable? Cubed. 2x cubed minus 6x squared plus 19x minus 55 plus 164 over the divisor x plus 3. How are we doing?
I did it.
Okay, cool. What? Oops, I went the wrong way. My bad.
I added the wrong.
Okay. Is this the next thing on your? Don't worry about it. It'll be fine. All right. So roots versus zeros. When it says find the roots, it means find roots are solutions to the equations. Okay? So when I say find the roots, it means find the solutions. How do you want to find the roots there? What do you do? What's the easiest way to solve that? Quadratic.
Quadratic formula.
I got you. It's completely square. You guys really, when you hear hoofbeats, you think zebras and elephants, but you don't think horses. What's the easiest way to solve a quadratic? Factor it.
Oh. I would have said flowers.
You did? Hi. How's it going so far?
Flowers.
Good. First two. Sounds better.
I know. I'll respond.
All right. So factor it. How's it factor?
Oh, you're second.
I'm second.
I feel like I'm three.
Are you up there?
X minus 3, x minus 6, x plus 3 equals 0. Yes? So your roots are 6 and 3. Okay. Now, let's say we look at a little different vocabulary. What if I didn't give you an equation? I just said find the zeros of this polynomial. Zeros are x's that make an expression 0. And they are the same. And so, if you set it equal to 0 and solve, obviously it's the same. So roots and zeros are different sides of the same coin kind of thing. It's just different vocabulary, all right? So when you hear roots or zeros, think the same. Let's say for the practice of it then, the problem is that when it says synthetic division, sometimes people aren't sure what the vocabulary means. When it says use synthetic division to show that 6 is a 0, then that is decision time. Do I put 6 or negative 6 into the box? No, it's actually 6, because remember I said, what do you put in the box? The zeros, the roots, yes? What the heck is wrong? Jeez, the freak. Okay, so would you please write it if you didn't already write it? And if you did, here. But you see, it says right here in step 2, put the root in a box. The root or the 0. Roots are solutions to an equation. Okay? So if I want to see if 6 is a 0 or a root, then it's 6 in the box, not negative 6. 6. Okay, so 1, -3, -18. And if it's truly a 0, then it should go in evenly, yes? All right. So if we carry this out, we get 0 here. So would you write yourself a note, please? If 6 is a 0, the remainder should be 0. And if you like, say, so x plus 6 goes in evenly, yeah? All right, one other thing that I want you to add into this. What is a 0 for a graph? Yes, x-intercepts. So if I were to do a real quick sketch of x squared minus 3x minus 18, I could put it in standard form and all that stuff, but I could just as easily say I know the zeros are at. So what are the x-intercepts? 6 and -3, and it opens. So factored form gives you x-intercepts. That is crucial, crucial, crucial. And I have to throw this out because my board is all whack. All right, flip it over and let's talk using synthetic division and some of the problems you'll see. All right, determine if -2, would you give us a side, please? Determine if -2 is a root to that equation. So what goes in the box, -2 or 2? -2. What goes in the box is the root. They asked is -2 a root? So what goes in the box is -2. Right? So what do you say? Why? Why do you say that?
Because it didn't equal 0.
It doesn't equal 0?
The remainder is 0.
Okay, this is not equal to 0, so -2 is not a root. I want you to give justification for why it's not a root. So I know that you're not just making it a 50-50, yeah, I said yes, but I don't really know why. It's because it didn't go in even. It has a remainder. That -2 is not a root. You follow? All right. Last but not least, this needs to be factored. And it's not factoring by grouping, which means your previous methods of factoring are out the door. But now, you have a way of factoring this. I'm telling you that 2 of the factors are x plus 1 and x plus 2. So when I'm done, I know that x plus 1 and x plus 2 are factors. How many other factors must there be? 2. 2 others. So the question is, what are the other 2 factors then? All right. Well, it's just like, remember back in the day when you prime factored, you did the towers and stuff, and they had you prime factor 120? Remember that? And you took out this, and you took out that, and you factored the smaller piece down, yeah? Same goes here. Start by factoring out x plus 1 synthetically. Okay, and your calculator is. Thank you. Here's your calculator. There you go.
Thank you.
You're welcome. Okay, so would you divide out x plus 1 synthetically, please? Remember, what goes in the box is the root. What's the root of the 0 of x plus 1? Negative 1. Now, if they're not lying to me, if x plus 1 really is a factor, then what should I see as a remainder?
Zeros.
I better see 0 as a remainder, or I did something wrong, or they're lying to me.
They did not lie.
They did multiple.
Okay. All right. Now, this is the hard part. You got to figure out where you stand now. You just took this x to the 4th and divided out x plus 1. What was left after you divided out x plus 1? That is what power? X cubed plus 0x squared minus 2x plus 4 is left. What if I multiplied all that back together? What would it give me?
When you got
It better equal that original thing, yeah? All right, cool. Now, I need to obviously factor this further. Now I factor this. Now I'm going to divide this by what? X plus 2. So now if I take out, what do I put in the box? 2 or negative 2? Negative 2 into 1, 0, negative 2, 4. Hello. Okay, what do you get?
What? Where? Yeah.
Okay, awesome. Now where do I stand? X plus 1. What else did I take out? X plus 2, and now what's left? X squared minus 2x plus 2. How do I solve this?
We just do it the old-fashioned way.
The old-fashioned way. Find the roots, and then it's x minus each root, right? So how do I find the roots of that? Does it factor or is it quadratic formula time?
It's just factor.
It does?
No, crud.
Wait,
It does not factor.
Oopsies.
I hate that.
It does not factor. So how do you solve this? How do you find the roots?
X equals
Negative b, so 2 plus or minus
b squared minus.
b squared minus 4 a.
All
Okay, this thing. Shut this thing down. Okay, so you're finding the roots because you don't have pencil issues, I assume. What are your solutions to that? X equals 2 plus or minus 2 root 2i over 2, which is 1 plus or minus I, yeah? Okay, so my factored form,
I just get 1 plus or minus I.
Yeah.
Because I have the 2 just cancel it out.
isn't this 2 plus or minus negative 4?
No, I get that part, but how do you go from 2 plus or minus 2i over 2 to 1 plus I?
2 plus or minus, so are you good there?
No,
And
yeah.
you said here, okay, so
I thought
that's
I meant
2 over 2, no. No. You never cancel part of the sum. What is this equal to? It's 5/4. Is it also equal to 1? No. Do you ever cancel part of the sum? Never. Never. Okay? So no, you cannot cancel those 2's. Don't even think about it. Instead, if you want, you could factor out a 2. That's cool. Okay, so factor form, what is it? X plus 1 X plus 2. X minus 1 minus I and X minus 1 plus I. Nope, 4 factors.
Why does it X minus 1? Oh my gosh.
So when you say you look at this, do you agree that this factors into x plus 3 and x plus 2? And do you agree that the zeros are the opposite, negative 3 and negative 2?
Yeah.
So factored form is x minus each solution. It's the opposite of each solution. Okay? All right. Here is your problem set. It says step 6 through 10. I don't know if that's doable or not. Let me look at it. Oh,
We need a more sad.
Okay, okay. Would you do 6 through 10, please? What color do you have? 6 through 10. Here's a calculator. Okay, so 6 through 10. Here we go.
Losing my mind.
You don't necessarily always get 0. I don't want to worry about this first. If you want to come in after school, 7th hour, you can see it. No, this your power is wrong. Execute divided by x is x squared. So your numbers are right, the powers are wrong. Again, your numbers are right, your powers are wrong. Yes. And it may have come equal, but same conclusion. I got a guess here. This is a 40. So I'll stamp those bad boys. Oops. If you have time to fix those, that'd be great. That's not the question. Maybe that's the question.
Oh, it's a 0.
Yeah.
Okay.
Yes,
it is.
And
That one.
okay. Thank you.
Hi. What?
I didn't. Oh yeah, I did. Okay, thank you.
Thank you.
This is not initiated plus in here, so it doesn't exist.
Oh, okay.
Okay, thank you. Isn't this easy? You're doing so great. This you didn't answer the question. Your division is right, but the question is it zero? So something like this, you should say negative 26 is not 0, that's zero. Equals 0, okay. Thank you. Why? Yeah, this one's not good, because that one is a Thank you. Alright, if you have time, real quick. I gotta copy this down. Okay. Thank you. Here's the room. Okay, thank you.
I didn't get that much time, but I just.
Okay, is it going well?
Yeah. I think.
Equals 0, so okay, thank you. Perfect. Have a great day, people.
Thank you, Mr. Rickman.
Thank you. Perfect. Thank you.